Good afternoon. We are the third team, and today we are going to talk about the process of the pharmaceutical pill package. Well, our project is about pill package. That is basically putting the pills into the container and that travels in a conveyor belt. The packaging of pharmaceutical products is basically making sure that the pills arrive in good condition to the customer to avoid falsification of the product or manipulation of this product by the kids. Um, thanks to this design, we have better results, and we make sure the creation of new functions like the upgrades are of better production. We had our 3D modeling system where we can see the first movement that is made by our project. We had this actuator A going going out and then pushing the container into the conveyor belt. The actuator B gets up and let the pills get into the container and then goes out. So these pills stops and the container can go to the next station. Then he goes to this place where the actuator C places a tap on the container to take another go. When he goes back, he take another one, and then the container keeps up moving and goes to this place where the actuator D on this movement D plus goes out and it stops the container from moving into with the conveyor belt. And then the actuator E has this movement that is E plus and locks the container so the lid can be put right, into the container. Then our next movement is the less, and then the actuator goes back and let the container travel into the conveyor belt. And then at the end of this conveyor belt, we have this like returns to make this movement to the next place, like the next step, where the actuator F make this movement F plus and pushes it out, and then it goes to this place where the actuator G go with G plus, and then it pushes the container out of the workstation, and then we can go to a deposit, so we can go to a market or every place where we're gonna put the pills. The description is where we develop like this actuator, what they have to do on every situation, and with this A plus and A less in every actuator. So it's like the resume of what we has in this place. We keep seeing it in this place because it's like pretty long, this equation of motion. Uh, we had our list of inputs and outputs, and we're going to show this. Actually, we had the inputs in here, that is our, our buttons, sensors. We have, quantify these things, and we had our list of outputs right here. We had engines, solenoids, control, light bulbs, phasers, and then we had our memories, where we're gonna see where they actually gonna help us a little bit more. We had a space phase diagram of the equation of motion. where we can show below where like the movements of every cylinder where when they when the equation of motion is, you know, in movement actually. And we had our actuator A, B, actuator C, D, E, F, and G, and we can see like this movement going out and then going in, and you know everyone has like a different initial position. Is just because they had different necessities by the equation we proposed. We had our electropneumatic diagram on this model step by step of the simulator. We we have 7 valves of failed jolt with electric drive. On the commands is where the regulate the energy of the devices, is where the on off buttons are 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 like it, etc. On the control part, each group is activated by the previous and is deactivated by the next one. Each group here is represented by the relay on their switchers. They connect the components that depends on the group. We can see it in this place, you know. On power, we can John the actuator marks the group over, and it depends on the sequence. Is your order that solenoid valves? You can see in this place. We have our graph set that it describes the automatic process taken into consideration by the actions carried out and proposed that its actions, and it describes from the initial points that begins in the cylinder is pairing on the starts of the cycle, as well as this station that it represents the process of the pill when the container is full at the rhythm of the conveyor belt. So on the other, the cylinder puts in place the container in order to the deposit, and in case of an emergency, they has a stop button. And we have the end of our graph set right here. We had our flow chart that is basically the same thing of the graph set, but you know, like with a different perspective. We have the start. When the gate is open, the pills goes in, the lid goes on, the lid and the cylinder goes out, and the end of the process. We have the ladder diagram that is actually the same thing of the step-by-step diagram. We can see our power in here. We can have our, our buttons and stops, and we have our mapping tables where we have the directions and the descriptions with the labels of the cylinders and the sensors, and then these directions actually has a place on the language of the PLC. So these things actually what's gonna be workable for us, you know, and that is it for us. If you have any questions, you can ask, and thank you for your time.